Good afternoon, everybody. Hope you're having a good day. This video is how to do a problem like number 2 on your worksheet. I have set up a problem similar, very similar, with probabilities just in reverse order. And I'm going to work through that, and hopefully you guys will be able to see how my work can help you do yours. So first we want to start off by solving for the value of k. That's step A. So we want to solve for k. You guys notice, and kind of why it throws you guys off, I think, is because normally you're given numbers here, but now you have a variable or a constant thrown in there. That is making things a little bit different for you. So we want to solve for k. And our first thought has to go to, what do we know that our probabilities have to be? We know that our probabilities have to be, any probability has to be between 0, or any probability has to be between 0 and 1. And all the probabilities added together, sum of our p's, or pi's really, has to equal 1. So when these add up, they have to equal 1, and that's particularly useful for this problem. So we know that all of these, this, when we add them up together, have to add up to 1. So since we're solving for k, this is just like an algebra problem. We have k plus 2k plus 5k plus 10k, since they sum up to 1, equal 1. These are all probabilities. And so now we add, since they all involve k, we add our like terms. We have 1k plus 2k is 3k. We add that to a 5k, that's 8k, and then we do that to our 10k. So we end up having 18k equals 1. And since we're solving for k, we divide by 18 here, we divide by 18 here, and we end up with k equals 1 over 18. For you guys that like in decimals, that's 0.055 repeating. Okay, so that's part A. Part B wants us to find the expected value and the standard deviation of x now. So we want to know e of x is our expected value, and our standard deviation, that is this little sigma. It's called sigma. It stands for S in the Greek alphabet, sigma. And so by doing that, we remember that from 6.1 we learned that to find expected value, we're multiplying our pairs together here, and then adding them all up. Okay, so what we have now is we start with our first pair, which is 0 and k. We have 0 times k plus our second pair, which is 25 times 2k, plus our third pair, which is 100 times 5k, and finally our fourth pair, which is 500 times 10k. Sorry, I ran into the side. 500 times 10k. We multiply these out. 0 times k is 0. 25 times 2k is 50k. Our third pair, 100 times 5k, is 500k. And our last pair is 500 times 10k. That's 5,000k. And now I know that some people might have added these up without remembering to substitute k in, but we know what k is. K is 1/18, so we need to put that in there. We need to plug it into each one of these. And when we do that, let's see, what's another color I have? We'll go with blue. When we do that, we get still 0 here, and we get plus 0 plus 50k, which is just 50 over 18, since k equals 1 over 18, plus 500 times, if you didn't understand how I did that, I just did this, 500 times 1 over 18. And the same thing here, which is 5,000 over 18. This could be over 18, but this is another way of showing it. Once you get that, I don't have a calculator on me right now, but we get 50 plus 500 plus 5,000 over 18, which is 5,550 over 18. And if I can find do a quick calculation here. That is 308.33. This will not be the same answer that you guys get on your problem, but it's the same process. So now once we do that, we have our e of x, we found it, it's equal to 308.33. And now we want to do the same thing with our standard deviation. So we know that our standard deviation actually equals the square root of our variance, square root of variance of x. And we have to find the variance of x first before we can find the standard deviation. So to do that, remember our formula is very similar. Variance, that's a nice color, variance of x equals 0 minus our expected value, 308. I'm going to leave it as 308 just to save some space, but it's 308.33 squared times our probability, which is 1k again, times k, and then that's our first term. Our second terms follow in the same way, 25 minus 308 squared times 2k plus, next line, 100 minus 308 squared times 5k plus our last term, which is 500 minus 308 squared times 10k. The same thing here, you're going to get a big number here. I'm actually not going to finish this calculation, as you guys should be able to do it on your calculators from here once you see this. But again, we need to remember that we already solved for k, so we need to plug it in to these different spots that it appears, just like normal. And you'll end up with a number down here. I don't know what it is. We'll just say that it's 40,000. And then our standard deviation is going to be the square root of that. Equals the square root of 40,000. So that is how we would do. This is a problem that is very much like part 2 on your worksheet.